Our next speakers are good friends of mine. We do work at the same company. When I'm not doing community things, my day job is I run the developer relations team for the platform team at Intuit. And so I have a question. I kind of already spoiled it earlier, but I have a question for you. Who has heard of the Argo project? Argo Proj. Okay. Keep your hands up if you knew that Intuit created that. Okay. How many people didn't know that Intuit created Argo and thought like maybe somebody else created Argo? Okay. Not that it matters. It's community. We don't sell anything. You know, I mean, Argo powers TurboTax and QuickBooks and Credit Karma and all that stuff, and so does Kubernetes, by the way. Huge Kubernetes instances, so that's why we got End User of the Year award twice at KubeCon. So we're really proud of the open source work that we do, and we have a booth out there, so if you want to talk to us more about open source and how you can get involved, we run a lot of open source meetups. If you think this is fun, come on October 20th, I think, at the Intuit campus. We do an open source meetup quarterly, and the next one is October 20th. It's on Luma, so you can find it. So, you know, Kubernetes is hard, right? You know, out of the box, it just, not everything works exactly the way that we would love it to, as much as we've tried as maintainers. But it's hard. And so we've had to do some things, customize some things in order to make it be able to run the ridiculously large infrastructure that we run at Intuit, to run the brands that I just mentioned. So we're going to talk a little bit about things that we've done with Kubernetes that, you know, maybe could work for you as well. So I'd love to welcome to the stage Yenkai and Estela. Yes, please.
Hi everyone, I'm Yenkai. I'm a product manager at Intuit for Kubernetes, for our Intuit Kubernetes services.
Hi, I'm Estela, and I'm a software engineer at Intuit.
All right, so let's get started. Our today's topic is Done for You Kubernetes. Done for You is our kind of a spirit at Intuit that we want to make the customer easier. So we want to make auto-scaling for our internal developer easy to be done and simplify the developer's workflow. I put this topic, hope we are charged by words, but it's basically want to get this easier for developer to use auto-scaling. The agenda of today will be, we'll cover the Intuit platform very short, and the background that we go from the horizontal pod autoscaler to our intelligent pod autoscaler, and later get into beyond that, what's a feature that we develop for developers, and we wish that if you are doing the same thing, your community, and hopefully get inspired by our solution. And if you want more technical detail, we're happy to hand it over to you. And as a PM, I will cover the problem statements, and my brilliant engineering partner, Estela, will cover the solution and demo. So firstly, let's cover our platform. Our internal developer platform has serving more than 8,000 developers at Intuit and hosting more than 1,000 of a CPU cores and 345 Kubernetes clusters. And if you know that, the TurboTax and the QuickBooks, those flagship products, are actually entirely hosted on Kubernetes. So if you are the tax filer and you kind of squeeze in the last minutes for April 15th to upload your 1099, then you are participating in our load test. And thanks for Kubernetes. I hope all your tax filing goes smoothly. Don't be charged by IRS. But yeah, we do leverage a lot, and we are the end user of Kubernetes for more than 8 years. So 15 years ago, we get into a public cloud, and in 2018, we fully adapt Kubernetes. And right now, we are taking a step forward to building on the top of open source Kubernetes and to build our own feature. So in terms of auto-scaling, that you can see the journey will be like before the Kubernetes, we don't have any auto-scaling. And with the Kubernetes, we have HPA, horizontal pod autoscaler. And on the top of them, we have an intelligent pod autoscaler that I want to cover. And today's topic will move beyond that. So before I dive into that, doing a quick poll that how many of you are familiar with HPA, horizontal pod autoscaler? Okay, great. So about a third of them. And so I will take maybe 1 minute to cover the very basic and why we are bringing this intelligent pod autoscaler. So as a PN, I want to take some analogy. So the background is that we want to make Kubernetes autoscaling highly available and reduce the cost, boost the utilization, and no one will be involved. Like no engineering effort will be spent on the tweaking this, how many pods do we need, and what's the min and max of that. So if you are taking the analogy of that, imagine you're running a grocery store and the pods, before the Kubernetes, you have a very fixed number of the cashier, or you see the processing units. And for all the service coming in, you cannot adjust anything. And with that, and if a lot of service coming in, the latency will boost and the cost incidence cause 500 error. And with the Kubernetes, you just like have a controller, which like an on-site supervisor, and you can increase the ready pod slots and set in the max of pods you can accommodate. And when there are more traffic, you just simply, Kubernetes will do it for you, that increase the pods number, so they can scale horizontally. The problem when we introduce this is that the developers still need to set the fixed number initially for min replicas and the max replicas. So that's getting to a problem that for developer who never get to Kubernetes, how do I know how can I set my min and max? So the building autoscaling falls short when they need to decide how to set the min and max. And how can they adjust it along the time if, for example, TurboTax has grown in user over a couple of years for like a double, and how can we increase the min and max? So it's like a second level of guardrail that even if I set the min and max, I need to make a decision if I need to, for example, increase the min so I can guarantee the basic SLA. So if a traffic surge, maybe the max will not be enough. So we have a mechanism to boost the max as well, but we need to consider all these 345 clusters added into it that would exceed the capacity of a cluster. So that is the problem we are solving with intelligent pod autoscaler. So it's basically the trade-off between if you over-provision, that you spend more money on the cloud cost, or if you under-provision, you will cause incidents. So it's like dilemma like this, which one you would choose. So take our analogy forward. If you are running a grocery store, just like running a pod autoscaler, the IPA, the intelligent pod autoscaler, cover more than that. That is, we have the long-term recommender, just like the consultant to look into a store, and the metrics like CPU and memories into the global updater. And we do it more than the real time, more than the runtime. We do it like 3 days, 5 days, and 2 weeks, and see the trends going on. If the traffic gradually pick it up, we will increase the min replica and the max replica to make sure there's no incidents. And there's a deployment pipeline, and here at Intuit we use Argo, Jenkins, and the GitHub issue to get it, Argo CD sync to the runtime namespace. So our journey will be like, before, maybe 10 years ago, people don't know about Kubernetes, and now, previously, before our new generation, they need to learn everything about Kubernetes because they need to make decisions themselves. They need to learn HPA, VPA, pod disruption budgets, and the carpenters. And now, they don't need to learn it. But is that true? Just like this bell curve, that previously, user know nothing about Kubernetes, and now they need to learn everything, and later they don't need to do anything. Is that right? So that is, well, I'll talk about the challenges we're encountering when we delivering down for you, when what's the problem derived into that. The problem in Derive will be because we have been on Kubernetes for so long that a lot of users, they are already learned about Kubernetes. So when we say it's done for you, we do it for you. Then they said, why do you pull the permission of me setting up the min and max out? So we are encountering the wide user spectrum of the knowledge about Kubernetes. There are some new users, they know nothing about Kubernetes, but they want to know how much resources, like CPU and memory, being allocated to their services. And there are some migrated users. They want to customize autoscaling as they need. If they run a perf test before, they want to guarantee they are previously 100 pods. Right now, it's still 100 pods running for their namespace. And the power user will be, they want more sophisticated because they maybe like 500 pods running every day, and they want to twist it in the very small granularity that at very beginning of the day, like 8 a.m., they were scaled up just 20 minutes before and scaled down at 6 p.m. How do we fulfill those requirements? Then I will hand it over to my engineering partner, Estela, to talk about the solutions.
Okay, thank you, Yenkai. So for the solutions, because we have a variety of different problems from different users, for the new users who don't have a lot of knowledge about Kubernetes or autoscaling, we wanted to make it very easy for them to understand what our recommendation engine is recommending for them. So for that, we build a UI for them to have insight on what recommendations we're sending them, what the changes in the recommendations, and what kind of different type of recommendation, whether it's changing your replica count or changing your CPU and memory. And then for the users who are accustomed to setting their own resources, we still needed to give them a way for them to give input to the autoscaling engine to say, hey, I always want to have like 1 core of CPU requests, don't ever go below that. So for that, we created the constraints feature, which gives the autoscaling engine that input, and we will respect those boundaries. And for the power users who have a different use case, who know when their app will be receiving traffic and when the app won't be, we needed a solution where they can set a schedule for them to scale up more pods and then to scale down when there's no traffic. And for that, we created a time-based pod autoscaler, which scales based on a specified schedule, which we'll demo in a bit. So here's an example of our UI. So initially, we provided users with like wavefront metrics chart to show them this is what we're recommending, and this is what the change is, and this is when it's happening. But the feedback was users were having a hard time understanding what the metrics were, and so we created a UI to give them better insight. So in the UI, they can see what the current app resources are, and for example, like everything from min, max replicas to what metrics their HPA is scaling on. And in the UI, you can also see what recommendation events are happening, which are different by the kind of operation. So here, a pod size change would mean we're adjusting your CPU or memory resources. And if you click on the details for one of the events, you can see here we're recommending you to lower your min and max replicas by 1. So this makes it a lot easier for users to understand what's going on with their app. And then for the users who still wanted to have an input on what resources their app should have, like as a minimum or a maximum, in the UI, they can also set the constraints. Here, if you tell us, like let's say my min replicas min allowed is 5, the autoscaling engine will take that as an input and it will never recommend anything below that. And some users want to cap their max replicas because they don't want to like increase cost. For example, for like perf environment or E2E environments. And there's some users who want us to have HPA scale sooner so they can reduce their target values, which their metrics are being scaled on. So this is what constraints looks like. And then for the third issue we were seeing was that we had a set of users who knew when they would be receiving traffic and knew when they would have no traffic. And we didn't have a way for them to configure this based on a schedule. So for example, if someone knows like from 8 a.m. to 6 p.m. I'll be receiving all traffic, after and before that, I don't need like 200 replicas. So for that, we looked at other open source solutions, and we saw KCD. KCD is a Kubernetes event-driven autoscaling solution, and it autoscales based on the number of events being processed. For our use case, we didn't need to scale on the number of events being processed. We just needed to scale based on a schedule. And so similar to KCD, we have a custom resource where you can define the schedule. And we have a controller, the time-based pod autoscaler, which reads the CR, and then it will emit a metric, so HPAs can scale on that metric. And this metric, it's the target replicas that you want. So this is kind of how we get to say, if we want 5 replicas, this is how it works. So the metric we're emitting would be 5, and if we have currently 3 replicas running, then because we're using average value for our metric in HPA will always try to keep this ratio as 1. So because 5/3 is not 1, it will bring up more pods until the average value is 1. So it'll stop when there's 5 pods running. And this is the demo.
Check if it works.
Okay, can you pause?
That's working. Yeah,
Oh.
it's working.
Okay, I don't know how to pause, but this is our custom resource where you can define your schedule, and here it's a cron. And our target replicas is 5, meaning we want 5 replicas. And the cron schedule is UTC time. And you can also do an absolute scale rule, which means you give a date and time. So between this date and this time, we want to have 5 replicas. And this is the target replicas metric we're emitting. The default value is 1. And currently, we're running 3 pods. And once the time for the cron begins, the value we're emitting will be now 5. So we emit the target replicas value. And so because HPA is trying to keep that ratio, it will bring up 2 additional pods.
Oh, sorry. Let's do it again.
Yeah. Okay, so there's 5 pods. And then once your end time of your cron is met, the target replicas metric should go back to 1. And this, it will try to scale back down to 1, but because our min replicas is 3, it'll keep our 3 pods running. So now it's scaled back down to 1. And if we go back to Argo, you'll see that the number of replicas we have is 3.
So it'll take
Yeah.
5 seconds for it to run.
Yeah, we're back to 3.
Yep. So I think we have a little bit more time.
Yeah.
We can cover a little bit more. Yeah. So I think the takeaway that from this is that while we are probably an end user, that we see that we can get inspired by other open source projects. Like previously, if we want to fully adapt KCD, then we need to introduce another CR and there's another controller that is adding more complexity. But we actually take a gist of them and build it into our own CR. and running the controller as our IPA because we're already building all of them. So we really appreciate that the open source community, that a lot of good idea that you don't, even if we don't directly adapt, and we can still learn from that. And it's easily built through this data inspire and set of metrics. I think it's a very clever way of a pattern that we can learn from, and we really appreciate the community.
Yeah, thanks. So in conclusion, we saw that we had a variety of different problems from different set of customers. So we had the customers who didn't know much about autoscaling, and we wanted to make it easy for them to understand our recommendations, so we gave them a UI. And then we had the customers who were used to customizing their own app, who still wanted to give some input, so we created constraints, and we respect those boundaries. And then we have the power users who have a different use case, who know when their app will be receiving traffic and when they won't be, and so they want to have like X amount of replicas running during that time and bring those down back to the minimum in order to reduce cost. So we created the time-based pod autoscaler. Yeah, so our takeaway from this journey is that when we're trying to build a done-for-you autoscaling, it's not like a one-size-fits-all solution. We have a different set of customers who have different needs. So what we've learned is that we need to take that feedback and provide different solutions, and we need to collaborate with our customers to be closer to a done-for-you experience. And if you want to keep in touch and be updated with what Intuit is doing in the open source community, you can scan the QR code. And then we have links to our previous presentations related to autoscaling as well. Thank you.